All right, so today we're going to talk about inverse variation. We're going to learn what an inverse variation is. We're going to talk about combined variations, and then we're going to talk about how do we use variations. So an inverse variation is a function with the relationship xy equals k or y equals k divided by x, where k is the constant of variation. So let's look at this. This is, according to the definition, a constant of variation. It's y equals 10 over x, where our k is 10. So if I'm going to graph that, if I'm going to put 1 in for x, y is going to be 10. If I'm going to put 2 in, y is going to be 5. If I'm going to put 5 in, y will be 2. If I'm going to put 10 in, y will be 1. Okay, so if I graph my points, 1, 10, 2, and 5, 5 and 2, and 10 and 1, I've got this little curve here. All right, I didn't draw that very well. So notice this is my inverse variation. Okay. So in our table, I want you to notice that as x is increasing, so if x is increasing, y is decreasing. Okay. So that's going to be the case with our direct variations. If one of them is increasing, the other one is decreasing. Okay. I also want you to notice that if you multiply x times y, in each case, you're going to get 10. 1 times 10 is 10, 2 times 5 is 10, 5 times 2 is 10, and 10 times 1 is 10. Okay. In our graph, now I've expanded it a little bit, and what you're going to notice is that it's going to have this nice little curve. It's going to go like this, and it's never ever going to touch the x or y axis. So it never touches either axis or goes through. Okay. Now what we call these axes then is we call them asymptotes. Okay, an asymptote is a line that a graph will never ever touch or intersect. It's going to get as close to that as possible, but it will never ever intercept it or touch it. All right. So here I've got some tables, and we want to decide if it's a direct variation, an inverse variation, or neither. So you reviewed yesterday direct variations, and remember direct is y equals kx, or k equals y divided by x, where an inverse variation is y equals k divided by x, or k equals xy. So we can use that fact to look at our tables and decide. Now, as I look here, this is increasing and this is increasing. So that's not going to be an inverse variation. So let's test to see if it is a direct variation. And to do that, we're just going to divide y divided by x. So 8 divided by 2/10 gives me 40. 20 divided by 0.5 or 5/10 gives me 40. 40 divided by 1 is 40. And 60 divided by 1.5 is 40. So this is a direct variation. And they want us to write a model, so it would just be y equals 40x. All right. Now in this case, my x is increasing, and my y, I should say increasing, probably goes this way, and my y is decreasing. So that could be an inverse variation. So now we just want to check. 2/10 times 40 is 8. Half of 16 is 8. 1 times 8 is 8. And 2 times 4 is 8. So this is an inverse variation. Okay. And that equation would be y equals 8 over x. So inverse 8 divided by x, right? In my case here, y is increasing, x is increasing, y is decreasing, so it could be an inverse variation. So let's look. Again, 40 times a half is 20. 1 and 2/10 times 12 is 14.4. So this is going to be neither. Okay. So now let's suppose that x and y vary inversely and x equals 8 and y equals -7. So we want to write a function that models that inverse variation. So k, remember, is equal to x times y. So k is going to equal 8 times 7, which is -56. So if we're going to put it into the equation, we're going to do -56 equals xy. That's a perfectly good model. Or -56 equals over x equals y. I would accept either of them. They're both inverse variations. So now we want to know what y is when x is 2, so we can just plug it into that equation and do the division. So -56 divided by 2 is going to be -28. So y would be -28. So we make that model so that we can find anything that we want. Okay. So another example, the ordered pairs below are from an inverse variation. We want to find the missing value. So again, we can find our k using this ordered pair. So k is equal to 5 times 8, or k equals 40. So my equation is y equals 40 divided by x. So if I plug in 32, and actually the model xy equals 40 might be better because we're going to put in 32 for y. So x times 32 equals 40. And we're going to divide both sides by 32. So x is going to equal 5/4 if I divide everything by 8. All right, so we're going to use the graphing calculator to help us determine whether this is an inverse variation or not. So I'm going to go to stat. In my list 1, I'm going to put my number of students. In list 2, I'm going to put the number of hours it takes to clean up the debris. Now, it looks to me like it is an inverse variation. The first list is increasing, the second one is decreasing. And what I'm going to do is I'm just going to look at the graph to see if it is. So I'm going to go to graph. It definitely looks like 1. Now the problem with inverse variations, when I go to calc, there's nothing that I can do that will give me that equation. So I can't have it calculate the equation for me. Now, what I'm going to do though is I'm going to take what I know about the inverse variations and see if I can come up with my constant of variation. And I know that k is x times y, or in this case, list 1 times list 2. So I'm going to go up to list 3, highlight it. I'm going to then go to option, and I'm going to go to list, and then I'm going to hit list again, which is F1. Okay, I'm going to put list 1 in here. I'm going to multiply it by list 2. So again, I'm going to do this OPTN key. I'm going to go to list again, list one more time, and list 2. And then I'm going to enter it. Okay. When I enter it, notice that everything in list 3 says 225. Okay, except for the last one. But that is close enough. Okay, so we know that our constant of proportionality, or our constant of variation, is 225. So our equation is going to be y equals 225 over x. So combined variation is when one quantity varies with 2 or more quantities. So we have jointly when you have 2 things varying directly. Jointly, z varies jointly with x and y and inversely with w. So we've got k xy divided by w. So here's another example. And then z varies directly with x and inversely with the product of w and y. So just some examples of combined. All right, so the number of bags of mulch that I need to cover a planting area varies jointly with the area to be mulched in square feet and the depth of mulch in feet. So if I need 10 bags to mulch 120 feet to a depth of 2 inches, how many bags do you need to mulch 200 feet to a depth of 4 inches? So I have the bags times the constant of variation times the area times the depth. Okay, so if I have 10 bags, because I've got to find k so that I can find the other situation, my area is 120 feet to 2 inches times k. So 10 equals 240k. If I divide both sides by 240, I get 10 over 240 equals k, or k equals 1/24. So my model with my joint variation is the bags is equal to 1/24 times the area times the depth. So now how many bags do I need to do 200 square feet at a depth of 4 inches? So bags equals 1/24 times 200 times 4. So bags is going to equal 1/24 times 800. Okay. And 800 divided by 24 is 33.3 bags. So I actually need 34 bags because I can't take a third of a bag. All right, so I'm going to need 34 bags to mulch 200 feet to a depth of 4 inches. All right, now we have the volume of gas varying directly with its temperature and inversely with its pressure. So volume is going to vary directly with its temperature, so K times its temperature, and inversely with its pressure. So volume equals K, T, and P. So if my volume is 100 meters when the temperature is 150 Kelvin and the pressure is 150, we want to find what the volume is in this other case. So once again, we got to find K. So our volume is 100 equals K. The temperature is 150 and the pressure is 15. So 150 over 15 reduces to 10. And then if I divide by 10, K is equal to 10. Okay, so now volume is going to be 10T divided by P. So we want to know what the volume is when the temperature is 250 and the pressure is 200. So our volume is 10 times 250 divided by 20. Now for me, it's probably easier to reduce 120 to 1/2, or 10 over 20 to 1/2, so that I get 250 over 2, and our volume is 125 cubic meters. All right, so hopefully today you learned what an inverse variation is, what a combined variation is, and how you use variation. Have a math-tastic day.